Now we take into a basic engine construction. The main component of an engine are engine block, cylinder head, combustion chamber, and other engine components. The engine block is made of nodular cast iron in an one piece for all cylinder number. The main bearing caps are fixed from below by two hydraulically tension screws. They are guided sideways by the engine block at the top as well as at the bottom. Hydraulically tensioned horizontal side screws support the main bearing caps. And the engine blocks contain cylinder bars, pistons and rings, connecting rods, crankshaft, bearings, timing gears, oil pan and filter, camshaft and lifters, which is pushrod engines, and also flywheel or flex plate. The internal diameter of a tube in which the piston of an engine or pumps move is called cylinder bars. It is a round hole cast in block which bored to a precise diameter and honed to smooth finish. It is a guide for piston and contains forces generated during four-stroke cycle, and some engines use steel sleeves. A piston is seated inside each cylinder by several metal piston rings, which also provide seal for compression and the lubricating oil. The inner surface of the cylinder is formed from either a thin metallic liner, which also called sleeve, or a surface coating applied to the engine block. Its main functions are to act as a seal against the combustion gases, as well as lubricant ingression into the combustion chamber. Another key function is to conduct the heat away to the piston and the liner, and both these requirements call for minimization of the gap between the ring and the bore. And the piston is a composite design with a nodular cast iron skirt and steel crown, and the piston skirt is pressure lubricated with ensure a controlled oil distribution to the cylinder liner under all operating conditions. Oil is fed to cooling gallery in the piston top through the connecting rod, and the piston ring grooves are hardened for good wear resistance. The piston ring set consists of two directional compression ring and one spring-loaded conformable oil scraper ring. And all piston rings have a wear-resistant chromium plating. And the piston moves up and down in cylinders to create low pressure to draw in mixture, to compresses mixture for ignition, transmit forces for combustion to rotate crankshaft, and pushes exhaust gases out of cylinder. A piston is seated inside each cylinder by several metal, which we call as piston rings, which also provide seals for compression and the lubricating oil. And the piston rings do not actually touch the cylinder walls. Instead, they ride on a thin layer of lubricating oil. The piston ring mounted in grooves on piston and takes up clearance in cylinder which required for piston expansion. It has compression, which is the two top rings that seal the combustion chamber, and oil control, which is at the bottom ring on the piston, which consists of three parts, which is two rails and expander. It will scrape oil from the cylinder as piston moves down on power stroke. In piston assembly, it consists of a piston, piston ring, and piston pin known as gudgeon pin. A piston is connected to small end of the connecting rod with the help of gudgeon pin. It guides the connecting rod when gas force is transmitted. The main function of a connecting rod is to form a link between a piston and a crankshaft. A small end of the connecting rod is connected to the piston with gudgeon pin, and a big end is separated into two parts for ease of assembly with crank pin. The two parts of the big end are bearing cap and the big end housing. Both are being bolted together, and this is done for ease of assembly of connecting rod with a crank pin. To supply oil to the big end, the oil hole is drilled from big end. The connecting rod of alloy steel is forged and machined with round section. The upper end is connected to the piston ring, which uses a bushing to allow movement on the pin, and the lower end is split to allow installation on the crankshaft journal, which uses precision insert bearing to allow rotation on crankshaft journal, and the bearing requires oil film at all times to prevent metal to metal contact with journal. And the lower end is split horizontally to allow removal of piston and the connecting rod throughout the cylinder liner. And all connecting rod bolts are hydraulically tightened, and the gudgeon pin bearing is of a 3-metal type, and oil is led to the gudgeon pin bearing and to the piston through a bore in the connecting rod. And then we go to the crankshaft. A crankshaft is a rotating shaft which, in conjunction with the connecting rods, that convert reciprocating motion of the piston into rotational motion. The crankshafts are commonly used in internal combustion engines and consist of a series of cranks and crank pins to which the connecting rods are attached. Crankshafts are usually made from metal, with most modern crankshafts being constructed using forged steel. And the crankshaft is supported by the engine block with the engine's main bearing, allowing the crankshaft to rotate within the block, and the up-down motion of each piston is transferred to the crankshaft via connecting rods. A flywheel is often attached to the end of the crankshaft in order to store rotational energy and maintain a more consistent rotational speed as the crankshaft receives energy from the connecting rod as a series of pulses. This assists in smoothing the power delivery and often in conjunction with harmonic damper, which attach to the other end of the crankshaft to reduce torsional vibration. And bearing is a device supporting a mechanical element and providing its movement relatively to another element with aluminum power loss. The rotating components of internal combustion engines are equipped with sleeve-type sliding bearings. It must have small hole for oil lubricating, and the purpose of lubricating of oil engine bearings are as a significant decrease of the coefficient of friction, the extraction of the heat generated by the friction, and removal of foreign material from the rubbing surfaces. And the pressurized oil keep bearing from contacting the journal. Rolling bearings, in which a load is transmitted by rolls or balls to a relatively small area of the ring surface, cannot withstand under the loading condition of internal combustion engine. Only sliding bearings providing a distribution of the applied load over a relatively wide area that may work in internal combustion engine. The sliding bearings used in internal combustion engines are the main crankshaft bearings that support crankshaft, providing its rotation under inertial forces generated by the part of the shaft and oscillating forces transmitted by the connecting rod. And main bearings are mounted in the crankcase, and a main bearing consists of two parts, upper and lower. The upper part of a main bearing commonly has an oil groove on the inner surface. A main bearing has a hole for passing oil to the feed holes in the crankshaft. Some of the main bearings may have thrust-bearing elements supporting axial loads and preventing movement along the crankshaft axis. Main bearings of such type are called flange main bearing. The second one is connecting rod bearings, which provide rotating motion of the crank pin with the connecting rod, which transmits cycling loads applied to the piston. Connecting rod bearings are mounted in the big end of the connecting rod. A bearing consists of two parts, which commonly interchangeable, and the third one is the small end bushes. Small end bushes provides relative motion of the piston relatively to the connecting rod joint to the piston by the piston pin, or we call it as gudgeon pin. The end bushes are mounted in the small end of the connecting rod, and the small end bushes are cycling loaded by the piston pushed by the alternating pressure of the combustion gases. And the last one is the camshaft bearings, and it supports camshaft and provides its rotation. Next, we go to the timing gear. A timing belt, timing chain, or cam belt is a part of internal combustion engine that synchronizes the rotation of the crankshaft and the camshaft so that the engine's valve open and close at the proper time during each cylinder's intake and exhaust stroke. In an interference engine, the timing belt or chain is also critical to preventing the piston from striking the valves. A timing belt is usually a tooth belt, a drive belt with teeth on the inside surface. A timing chain is a roller chain. Timing chains are generally more durable than timing belts, though neither is durable as gear drive. However, the timing belts are lighter, less expensive, and operate more quietly. And valve needs a system to make them open and close. Control of the valve is accomplished through the use of cams on a common shaft. A shaft is an egg-shaped piece, which is the lobe, mounted on the camshaft, and the egg shape of the cam lobe is designed to lift the valve open, hold it open, and let it close. The camshaft is timed to the rotation of the crankshaft to ensure that the valve opens at the correct position of the piston. Timing the valve opening to the piston is critical to ensure proper power output and low emission operating of the engine. So-called cam-in-block engine use push rods to transfer the camshaft lifting motion to the valve by way of rocker arm on top of the cylinder head. The tapered of lifters right on the camshaft lobes to actuate the push rod, rocker arms, and the valve. The timing of the camshaft is all operated through the cam belt or timing belt, which is synchronized with the movement of the crankshaft. During the four-stroke combustion cycles, which are intake, compression, power, and exhaust, the crankshaft turns twice, where it moving each piston up and down twice, while the camshaft turns once. This results in each valve opening one time for every two crankshaft revolution in relation to the piston. This way, only the intake valve will open on the intake stroke, and both valves remain closed during the compression and combustion stroke, and only the exhaust valve opens during the exhaust stroke. The motion of the engine valve is driven by the camshaft of the engine, which contains a series of lobes or cams that serve to create linear motion of the valve from the rotation of the camshaft. The intake valve on the internal combustion engines are subject to less thermal stress because of the cooling effect of the incoming air or fuel mixture that passes by the valve during the intake cycle. The exhaust valve, by contrast, are exposed to higher level of thermal stress by being in the pathway of the exhaust gas during the exhaust cycle of the engine. Intake valves, because of their lower operating temperature, are typically made of material such as chrome, nickel, and tungsten steel. The higher the temperature exhaust valve may use more heat-resistant metals such as nichrome, silicon chromium, or cobalt chromium alloys. Valve faces may be coated with stellite to reduce wear and corrosion, and the valve faces are ground to 30 degrees for intake airflow and 45 degrees for cooling and for exhaust. The valve arrangement in an engine controls the in and out movement of charge and exhaust gases in the cylinders in relation to the piston position in their bars. Currently, this is located in the cylinder head on all the engines. Among the commonly used sleeve, sliding, rotary, and poppet types of valve, the poppet valve is most common because this offers reasonable weight, good strength, and good heat transfer characteristic. The most popular shape of the poppet valve for automobile application uses a small cup at the end of the stem. The valve stem is placed in a guide hole made centrally in a circular passage in the cylinder head. The valve disc head opens and closes the ported passage leading to the cylinder during in and out movement of the stem. Both inlet and exhaust ports are shaped to curve upwards and outwards, emerging from one or both sides of the cylinder head. It is normal to have one inlet and one exhaust valve and port per cylinder. However, twin inlet and exhaust valve and port layouts are also adopted for some high-performance or large-capacity engines. Also, a few engines use twin inlets but only one exhaust valve. Valve may be positioned vertically or slightly inclined relative to the cylinder axis, matching the desired combustion chamber contour. Poppet valves have different configuration within the engine relative to the cylinder. In the overhead cam engine, the camshaft is mounted in the head either above or to one side of the valve, which improves valve action at higher engine speed. The valve is operated directly by means of valve lifter or cam followers or through rocker arms. In the overhead valve engine, the camshaft in the engine block and the valve are operated by valve lifters, push rods and rocker arms. The double overhead cam engine has two camshafts placed on each side of the valve. One operates the intake valve and the other operates the exhaust valve. And a flywheel is essential, a very heavy wheel that takes a lot of force to spin around. It might be large diameter wheel with spokes and a very heavy metal rim, or it could be a smaller diameter cylinder made of something like a carbon fiber composite. Either way, it's kind of wheel you have to push really hard to set it spinning. Just as a flywheel needs a lot of force to start off, so it needs a lot of force to make it stop. As a result, when it's spinning at high speed, it tends to want to keep on spinning, or we could say it has a lot of angular momentum, which means it can store a great deal of kinetic energy. You can think of it as a kind of mechanical battery, but it's storing energy in the form of movement, which is the kinetic energy, in other words, rather than the energy stored in chemical form inside a traditional electrical battery. A flywheel is a heavy steel plate mounted to the crankshaft, which it smooths out power pulses to keep engine spinning smoothly and serves as mounting surface for clutch on manual transmission. And then we go to the cylinder head. Cylinder head is usually located at the top of the engine block. It serves as a housing for components such as the intake and exhaust valve, spring and lifters, and the combustion chamber. The passage in the cylinder head allows air and fuel to flow inside the cylinder while permitting the exhaust gases to flow out of it. The passages are otherwise called ports or tracts. The cylinder head also channels the coolant into the engine block, thereby cooling down the engine component. The cylinder head uses a gasket that aids in preventing water or oil from leaking into the combustion chamber. Most cylinder heads are made out of a cast iron. A cylinder head made of cast iron is more durable and less expensive. However, cast iron is very heavy and provides a lesser efficiency in dissipating heat. For this reason, some manufacturers prefer using cylinder heads made of aluminium, and these cylinder heads are much lighter than cast iron cylinder heads. Performance cars and race cars commonly have aluminium cylinder heads. A combustion chamber is an enclosed space inside a combustion engine in which a fuel or air mixture is burned. Burning fuel releases a gas that increases in temperature and volume. When you heat a gas, the atoms in the gas start bouncing off each other with more energy. The hard bouncing causes them to get thrown out farther and the whole gaseous cloud expands. The oil sump is also referred to as the oil pan, oil tray, or oil reservoir. The oil sumps are used for both 4-stroke and 2-stroke internal combustion engine. All engines require a lubrication oil system. All engines require a lubrication oil system, also known as lube oil system. Typical systems include an oil sump or reservoir, oil pump, oil filter, and all associated piping. An oil filter removes foreign bodies from the oil. The foreign bodies are typically items such as metal shaving, dirt, and dust. Clean oil is discharged from the filter and enters the engine. The oil lubricates all the engine's reciprocating or rotating parts and then drained back to the oil sump. And normally the oil filter is usually mounted on the engine block.